Welcome to the future of materials science, where innovation meets nature's wisdom. Imagine a world where cracked roads can repair themselves, or your damaged phone screen can heal overnight. This might sound like something out of a sci-fi movie, but it's quickly becoming reality thanks to self-healing materials. Self-healing materials are designed to automatically detect damage and initiate repair without any human intervention. Much like how our skin heals itself after a cut, these materials respond to cracks, scratches, or other forms of wear and tear. So, why does this matter? Because industries like construction, aerospace, and electronics are starting to realize the incredible potential of self-healing materials. They could dramatically reduce the need for repairs, cut down on waste, and extend the life of everything from buildings to smartphones. In this video, we'll explore how this revolutionary technology works, and why it's set to transform the world as we know it. Let's dive in. Now that we've introduced self-healing materials, let's take a closer look at the science behind how they actually work. At the heart of these materials is a fascinating process that mimics biological healing. There are different types of self-healing mechanisms, but the most common involve one of three approaches: capsule-based healing, intrinsic healing, and vascular networks. Capsule-based healing works like this. Tiny capsules filled with a healing agent are embedded within the material. When the material cracks or gets damaged, these capsules break open and release the agent, which reacts with the surrounding material to heal the damage. Intrinsic healing is when the material itself can repair damage without any external agents. This is often seen in special polymers where the molecules are designed to reconnect or rebond when exposed to heat, light, or certain chemicals. Then there's vascular self-healing, which is similar to how our blood vessels work. In this approach, networks of tiny hollow channels are built into the material. When damage occurs, healing agents flow through these channels to the damaged area, like blood clotting at a wound site. These mechanisms allow self-healing materials to restore their structural integrity and function over time. Whether it's sealing a crack in a bridge or repairing a scratched smartphone screen, the technology is advancing rapidly, pushing the boundaries of what's possible. In the next chapters, we'll explore how these self-healing materials are being applied in real-world industries like construction, electronics, and even aerospace. One of the most exciting and practical uses of self-healing materials is in the construction industry. Imagine a future where roads, bridges, and buildings can automatically repair cracks and damage, extending their lifespan by decades. That future is closer than you might think. Self-healing concrete is at the forefront of this innovation. Traditional concrete is strong but prone to cracking over time due to weather, stress, and use. Cracks can allow water and chemicals to seep in, weakening the structure and leading to costly repairs. However, self-healing concrete works differently. It's designed with either special bacteria or microcapsules filled with healing agents. When cracks form, these agents are activated, filling in the gaps and sealing the damage, often without any human intervention. For example, scientists are using bacteria that produce limestone when exposed to water and oxygen. As cracks form and moisture seeps in, the bacteria begin to work, producing a natural cement that fills in the cracks. This process can prevent small cracks from becoming larger, significantly reducing the need for maintenance and repairs. Several real-world projects are already testing self-healing concrete. In the Netherlands, some roads and bridges have been built with this material, and early results are promising. Imagine the cost savings in cities, where repairing potholes and infrastructure damage is a constant challenge. But it's not just concrete. Other materials, like asphalt and metal, are also being developed with self-healing properties, making future infrastructure projects more durable and sustainable. In the next chapter, we'll take a look at how these materials are transforming the electronics and consumer goods industries. Now let's shift gears and explore how self-healing materials are making waves in the electronics and consumer goods industries. We've all experienced the frustration of a cracked smartphone screen or worn-out electronic devices. What if your phone could repair itself overnight, or your electronics could last much longer without the need for costly repairs? Thanks to self-healing polymers, this future is becoming a reality. Self-healing polymers are special plastics designed to restore themselves after sustaining damage. These polymers contain molecular bonds that can break and reform when exposed to certain triggers, like heat, light, or even electrical currents. For instance, if a polymer-based device is scratched or cracked, the material's molecules respond by rebonding, effectively healing the damage. One exciting application is in flexible electronics, like wearable devices and foldable screens. These materials can bend, stretch, and self-repair, making them perfect for the next generation of durable, long-lasting gadgets. This not only enhances the user experience, but also reduces electronic waste, which is a growing concern as we produce and discard more devices each year. And it's not just phones. Self-healing polymers are being developed for smart coatings, which could automatically repair scratches on cars, appliances, or even furniture. Imagine never having to worry about small scratches or chips in your electronics or household items again. These innovations are not just about convenience, they're also a step toward a more sustainable future where we use fewer resources and reduce waste. In the next chapter, we'll dive into how self-healing materials are being applied in the aerospace and automotive industries, pushing the boundaries of what's possible in engineering. Self-healing materials aren't just transforming construction and electronics. They're also making a major impact in the aerospace and automotive industries, where safety and durability are critical. In the aerospace industry, self-healing materials are being developed to repair minor damage in aircrafts, satellites, and even spacecraft. Imagine an aircraft experiencing minor damage from debris or extreme weather. Instead of grounding the plane for repairs, the material could heal itself while still in flight. This is possible thanks to self-healing polymers and composites, which can detect damage and respond by filling in cracks or tears. This not only improves the safety of the aircraft, but also reduces downtime and maintenance costs. In spacecraft, where even the smallest damage can have catastrophic consequences, self-healing materials could be a game changer. Space missions could be safer and more efficient, with less risk of mission failure due to micrometeoroid impacts or environmental stresses. Scientists are already working on integrating these materials into space exploration systems, bringing us closer to a future where spacecraft can self-repair in the harsh environment of space. Meanwhile, in the automotive industry, self-healing materials are being used to create more durable vehicles. Think about it. Cars experience wear and tear every day, from minor scratches to cracks in the bodywork. Self-healing coatings, like scratch-resistant paint, can repair these small damages without any need for intervention. This not only keeps cars looking new for longer, but also reduces the need for expensive repairs. In fact, some car manufacturers are already experimenting with these technologies, and we could see self-healing cars on the road in the near future. It's an exciting prospect that combines innovation, safety, and sustainability. As we can see, self-healing materials are pushing the boundaries of what's possible in engineering, making transportation safer and more efficient. In the next chapter, we'll take a look at the environmental and economic benefits of self-healing materials and why they're more than just a cool innovation. They're also a sustainable solution for the future. Self-healing materials aren't just an engineering marvel. They also have significant environmental and economic benefits that could reshape industries and help create a more sustainable future. Let's start with the environmental impact. One of the biggest challenges we face today is the enormous amount of waste generated from damaged goods, especially in industries like construction, electronics, and transportation. Think about all the cracked phone screens, worn-out car parts, and crumbling infrastructure that need to be replaced every year. Self-healing materials could drastically reduce this waste by extending the life of these products. When materials can automatically repair themselves, They don't need to be replaced as often, leading to less consumption of raw materials and fewer items ending up in landfills. Additionally, self-healing materials can reduce the carbon footprint associated with repairs and maintenance. For instance, in the construction industry, fixing cracks in roads and bridges requires heavy machinery, transportation, and energy. With self-healing concrete, these repairs can happen on their own, cutting down on the emissions associated with traditional repair methods. The same goes for cars and aircraft. Fewer trips to the mechanic means fewer emissions from transportation and production. Now let's talk about the economic benefits. Industries that adopt self-healing materials stand to save billions of dollars in repair and maintenance costs. In infrastructure, for example, governments spend massive amounts of money each year on road repairs and maintenance. By using self-healing materials, those costs can be significantly reduced over time, allowing more funds to be allocated to other critical areas. Similarly, companies in the automotive and electronics sectors could see substantial cost savings by reducing the need for warranty claims and repair services. Consumers, too, will benefit. Imagine owning a car that rarely needs expensive repairs, or a phone that doesn't need replacing every time the screen cracks. Self-healing materials will make products last longer, which means people can save money on replacements and repairs. Overall, self-healing materials offer a win-win scenario. They're good for the planet and good for the economy. By reducing waste, cutting emissions, and lowering costs, these materials are poised to play a major role in creating a more sustainable and efficient future. In the next chapter, we'll explore some of the challenges that still face self-healing materials and what's next for this groundbreaking technology. While self-healing materials hold incredible promise, there are still some significant challenges that need to be overcome before we see widespread adoption across industries. One of the biggest hurdles is cost. Right now, developing and producing self-healing materials can be expensive. For many industries, it's cheaper to use traditional materials, even if they require more maintenance and repair over time. For self-healing materials to become mainstream, scientists and engineers need to find ways to lower production costs and make these materials affordable for widespread use. This includes optimizing manufacturing processes and sourcing cheaper raw materials without sacrificing performance. Another challenge is scalability. While self-healing materials have been proven to work in controlled lab environments and small-scale applications, scaling these technologies for large projects, such as entire bridges or commercial aircraft, remains difficult. The complexity of integrating these materials into existing infrastructure and systems is another barrier that researchers are working to solve. Additionally, there's the question of durability. While self-healing materials can repair small cracks and scratches, how well do they hold up under more extreme conditions? In industries like aerospace and construction, materials need to withstand harsh environments, extreme temperatures, and constant stress. There's still ongoing research to ensure that self-healing materials can maintain their effectiveness in these demanding applications. Despite these challenges, the future prospects for self-healing materials are incredibly exciting. Researchers are continually improving the technology, finding new ways to make it more cost-effective, scalable, and durable. In the near future, we might see self-healing materials becoming the standard in everything from construction to consumer electronics to transportation. One promising area of research is the development of multifunctional materials, materials that can not only self-heal, but also change shape, conduct electricity, or adapt to environmental conditions. This could open up a whole new world of possibilities for innovation. As industries continue to push for more sustainable and efficient solutions, self-healing materials will play an essential role in shaping the future of engineering and technology. In the final chapter, we'll wrap up everything we've learned and reflect on how self-healing materials are driving us toward a new era of innovation and sustainability. As we've explored, the world of self-healing materials is nothing short of revolutionary. These materials, capable of repairing themselves, are set to transform industries ranging from construction and electronics to aerospace and automotive. Imagine a future where cracked smartphone screens, damaged bridges, and worn-out car parts can heal themselves, reducing waste and cutting costs. Despite the hurdles of high costs and scalability, the relentless drive of researchers and engineers is bringing us closer to a world where self-healing materials are commonplace. The potential environmental and economic benefits are vast: less waste, fewer repairs, and longer-lasting products. As industries strive for greener, more sustainable solutions, self-healing materials will undoubtedly play a crucial role. We are on the brink of a new era in engineering, one where materials are not just durable but smart and adaptive. This evolution in material science will redefine our approach to sustainability and innovation. So, the next time you see a cracked sidewalk or a scratched phone, envision a world where those things could simply heal themselves. That future is closer than you think. Thank you for joining us on this journey into the future of self-healing materials. If you enjoyed this video, please like and subscribe for more insights into the latest breakthroughs in science and technology. Until next time, stay curious and keep exploring.